they never happen on the same object. Action happens on one object, reaction happens on another object. So let's say you have a rope and there's a mass hanging from this rope. If you consider the rope to be light, like in our case, the rope is extremely light, we can draw the forces on it. For the mass m, you'll have a tension because the rope is tight, so rope is pulling the mass up and its weight is acting downwards. Same way, if you talk about the rope, this is our rope. The rope is being pulled by the mass with the same amount of force, T. Action and reaction. Action and reaction happens at the point of contact, not anywhere else. I hope this one is clear. So let's take a look at how to solve certain problems involving Newton's laws. Let us try to solve the simple problems first. We have already seen one of the examples with one block, and let's try with two blocks. Let us say that you have got two blocks, one is 1 kilogram, the other is 4 kilograms, and they are being pushed by a force of 10 newtons. Now we have to find what is the acceleration of these two blocks. The first thing in mind that should occur to us is we should draw all the forces on each of these masses separately. This is also known as the free body diagram. In a free body diagram, you just show the forces which are acting on one object. Only on one object. We don't talk about the other object. So let's draw the free body diagram of 1 kilogram mass. For the 1 kilogram mass, you have a 10 Newton force. Now 1 kilogram mass is in contact with 4 kilogram mass, so therefore you must have a reaction from 4 kilogram mass, which is towards the left. Let's call that reaction to be R. There's a weight of this 1 kilogram object, that will be 1 times G. We are assuming that this is on a very smooth platform, very smooth table, you can say, these two masses. So the table will also exert a reaction force. Let's call that R2. So these are the forces that we have drawn on 1 kilogram. Same way we can draw it for the 4 kilogram block. For the 4 kilogram block, you have a reaction, or we can say an action force from 1 kilogram. Keep in mind that these two are same. This R and this R. They both are same, but in opposite direction, because they are action and reaction pairs. They have to be in opposite directions. There is a weight 4G which is acting downwards, and that's it. These are the only two forces acting on the 4 kilogram mass. Now we are saying that we have a very solid platform, so they are not moving in the vertical direction. They are only moving in the horizontal direction. Now if they are moving in the horizontal direction, we can write certain equations for the horizontal only. The horizontal forces for the 1 kilogram are 10 minus R equals 1 into A1. 10 is the force which is acting towards the right. R is the force which is acting towards the left. We are assuming that our mass, 1 kilogram mass, is moving towards right. You can assume it to be anywhere. You can assume also that it moves towards left, then it would be r minus 10. However, we know that this is not going to happen. So 10 minus r equals a1. Same way, for the 4 kilogram block, we can write as r equals 4 times a2, because the only force acting horizontally for the 4 kilogram mass is r. So r equals 4 times a2. Now we can add these two equations to eliminate r, and we will get 10 equals 4a2 plus a1. This is the final equation that we get. Now, how do we find the accelerations? We don't know that yet. What is the relationship between a2 and a1? We have to find that out. Now, how to find that thing out? This is also known as constraint relation. A constraint relation is a physical restriction that our objects cannot overcome. They have to move with the constraint in place, or with the physical restriction in place. We know that the 1 kilogram block and the 4 kilogram block, they do not lose contact. So that means they must move with the same accelerations, because if they do not lose contact, they cannot have different accelerations. So I'll say that a2 equals a1. With this relation in place, we can write 10 equals 4a, we can make this to be a, plus a, or acceleration equals 10 over 5, that is 2 meters per second square. Now this is the acceleration with which these two masses move. I hope this one is clear. Check out the other parts as well for more interesting problems. Thanks for watching.